First question on the Calc Active is this question here. We have the diagram, it's a rectangle, and we have a width here marked as X. And the question tells us that the length is going to be 20 centimeters more than 3 times the width. So what we need to do here is look at this information and turn this into some sort of algebraic expression. So 20 centimeters more means plus 20. 3 times the width. 3 times the width means 3 multiplied by the width, which is x. So that'll be 3x. And that will give us an expression then of combining those two things is 3x plus 20. So the length is 20 centimeters more than 3 times the width. So here, and then we would mark that on our diagram. And that gives us connection back to the diagram because we might not know what the next question is going to ask us. And then when we look at the diagram, we know that we've already found the length. And so if the question asks us about length, we've got a direct connection to it. We're not trying to remember that later on. We've actually included it already. Part B asks us to find the area. And it gives us this rule for area. So now we can just substitute in the values we know. The length we know is 3x plus 2. Sorry, 3x plus 20. And we're going to multiply that by the width, which is x. Now, the important thing to remember here is that this 3x plus 20 is contained. So you need to understand that you've got to put brackets around that because otherwise BODMAS is going to push you towards just doing the 20 times the x and give you the wrong outcome. Now, that then asks, you're then asked to expand that. So what that really means is to take this and to multiply. So we end up here, this actually becomes x 3x plus 20 in this format. And then we can do the multiplication. So x times 3x is 3x squared. And then x times 20 is plus 20x as our expanded answer. Part C tells us that our tiles are going to be put onto a rug, and this rug has an area of 180 squared plus 120x. And we're asked how many tiles are going to fit on the rug. So in other words, we need to do a division question here. So 118x squared plus 120x divided by 3x squared plus 20x, which is the area we found of the tile in the previous question. So to do that, we need to create this division question. And as we know with algebraic form, division is generally represented as a fraction. When we see a question like this, the first thing we should be thinking is we want to cancel, but we know we can't cancel when we've got these addition symbols here. We can't cancel top and bottom, so we need to factorise first, and that will give us the multiplication part which allows us to do the cancelling. So we're looking here and we're seeing that we've got some common elements here, x squared and x, 20 and 120, 3 and 18. So there's connections all around here. Okay, so we want to factorise this particular question. So we're looking what's common to both the top and the bottom here. And we can see that what's common here is 20 is common to both here. So plus 20. And here we have 3x. And here we'll have 3x plus 20. And then here it'll be 6x times that. And then 6x times 20 will give us the x that'll need to go on here. And then outside of this one, it'll just be x, like that. So this then allows us to see 6x by 3x gives us 18x squared, 6x by 20 gives us 120x. X times 3x gives us 3x squared, and x times 20 gives us 20x. So now we've factorised this. We know there's a multiplication sign in here and in here, so that means we can cancel. So we can cancel that with that, okay? And then obviously we can also cancel that x plus that x because that's 6 times x is that 6x, and that leaves us simply with a 6 left over. So our answer is 6 to how many tiles will fit on that rug. Finally, part D asks us to consider that if x equals 12 let's work out the actual area of one of these tiles. So it says one of these tiles, so we can go back to the area expression that we found out earlier on in the question, and we can pop down here, and now we just want to substitute in the value of x equals 12. So my advice is always write down the expression first, and then we're going to fill down underneath it. Okay, so it becomes 3 multiplied by x squared, which is going to be 12 squared. And we're going to add on to that 20 multiplied by 12. Now 12 squared is going to be 144, okay? So 144. So we've got 3 times 144, which is going to be 432. And we're going to add on to that 12 multiplied by 20, which is 240. And that's going to give us a final total of 672. And it tells us in the original question that these are all in centimetres. Yep, centimetres. It tells us that it's in centimetres, so it's going to be centimetres squared. Question 2 gives us quite a bit of information to start with. It tells us that A is an adult ticket, C is a child's ticket, and P is a pensioner's ticket. And it gives us an example of A plus 3C means an adult ticket plus 3 child's tickets, so 3 child's 3C. Then it says, what does this mean? And so the answer to this would be that 2A would be, it means that that's 2 adult tickets plus 4 child's tickets or children's tickets. And then 3 pensioners' tickets. Next part of this question asks us to do some substitution, and tells us, okay, so to reuse this same expression, so we have 2 multiplied by A, which is $23.40, plus 4 multiplied by $15.60, plus 3 multiplied by $17.50. And this is calc active, so we're able to use our calculator to solve that. And we can see here that that's 46.80, 62.40, and 52.50. And that gives us a final total of $161.70. Part C asks us to find out write an expression for 2 adults and 2 children. So thinking back to our original, 2 adults was actually in the original expression we were given. 2 adults plus 2 children would be the expression that we could write. So 2A plus 2C. And then we could use substitution to find out the cost of what that's going to be. So that's going to be 2 multiplied by 23.40 plus 2 multiplied by 15.60. Okay, and I think with calc active questions, it's the writing of this step here that often is the bit that students will skip past, because they'll perhaps will write that down because it's required, but then they'll do all of this on their calculator and then press equals. And the difficulty with that strategy is that one missed button, one incorrectly pressed button, means that your answer is going to be incorrect. So showing your total working as you go is a far better strategy. If we calculate that out on our calculator, it gives us a total of $78 even. Then part D asks us to use that answer and say, well, if we're comparing that answer to a family ticket, what is the difference in the price? So it's going to be $78 take away $68.90. And again, this is a calc active part of the paper, so you'll be using your calculator to do that, and it will tell you that it is $9.80. $9.10, and what it tells you, and then it's $9.10, but it's also asking you if it's more expensive or cheaper to buy the family ticket. So that you can see here that the family ticket is cheaper than buying the tickets individually, so it's $9.10 cheaper to buy that family ticket. So it's important that not only you get the price with a dollar sign, but you also get the cheaper element so that it answers the actual full question that you're being asked. Okay, question 3 gives us this information that outdoors it's negative 11.6, so minus 11.6, so it's cold. And there's a control box inside that's 24.3 degrees, so that's quite warm. And then it asks you what the difference is. The one thing I would say with all of these types of questions is to just think logically first rather than just try to mathematically solve it, because that thinking will mean that you can look at your answer and think whether it's reasonable. So the difference between these two amounts, so negative 11 to 24.3, we want to add those two numbers together effectively. So realistically, this is the equation, it's 24.3, take away negative 11.6. And that gives us 24.3. Negative and a negative gives us a positive 11.6. And so we can see here that it's going to be about a 30-degree difference between those two. You can imagine between it being minus 11 in the morning and then 24 degrees during the day, it's about a 30-degree shift in temperature. So your answer needs to be in that sort of range, and of course it's 35.9 degrees, 90, and it's degrees Celsius. And this bit here is crucial. This tells us what it is. We've done dollars, we've done percentages, we've done centimeters, we've done lots of measurement in these questions. So telling us what you're measuring is crucial. So this can't be left off. And it's one of the things I think we need to be taking note of is the information that you're given. It tells you what's required in terms of the number and the measurement type. So make sure you're replicating that with your answers as you go through. Next one tells us that we've got these woolen suits and they need to be in a situation where they're at least 34 degrees warmer. So it's telling us what's the temperature need to be for that to be the case. So we've got negative 11 outside, negative 11.6, and we're going to add on 34 degrees. Now again, it's a calc active task, so 11.6 into your calculator, add on 34, and that's going to give us a positive value of 22.4 degrees Celsius. 22.4 degrees Celsius. Now if we look 22.4 and 24.3, we can see that the control box would certainly deal with that. Next question talks about the outdoor temperature dropping by half a degree every minute, dropping. Okay, so if the temperature outside is a negative 11.6 and it's going to drop, then this number here needs to get smaller. Now, what we need by smaller is further away from 0. So we're imagining 0 and we're imagining negative 11.6, and to get smaller, so the temperature is dropping, it's going in that direction. So be thinking along those lines as you go to calculate this. So it says after 4 minutes, how much has it dropped? Okay, so that's 0.5 multiplied by 4 is going to equal 2 degrees Celsius. It's going to drop by 2 degrees. So 11.6, negative 11.6 rather, and it's going to drop by 2 more degrees. It's going to become negative 13.6 degrees Celsius. We now have this competition where we have these visitors in this competition, and there are green cards which give you -2 points and red cards which give you 3.1 points, and we have this table with their accumulated green and red points. We are asked to calculate their totals. We're also asked to show all the working. So in this, it's really crucial that becomes part of how you tackle this question. So let's look here. So it's 7 green cards. So it's 7 multiplied by -2. And then it'll be 5 multiplied by -2. And then for the red cards, it'll be 4 multiplied by 3.1, and then 3 multiplied by 3.1. Again, it's a calc active task, so please make sure that if you want to do calculations, that you're using your calculator to do that. And then in our total here, we want to represent what's happened here in the total. So we want to have an equation and an answer here. So 7 multiplied by -2 is -14. And we want to add on to that 4 multiplied by 3.1, which is 12.4. And here we've got 5 by -2 is -10. And we want to add on to that 3 times 3.1, which is 9.3. So we've got these there, and then we want to have those as totals. So -4 plus 12.4. Now I'm just going to rub this out because I'm running out of space. That's going to give us -1.6. And then -10 plus 9.3 is going to give us -0.7. Part B of this particular question says, which person is the winner? And you need to also show mathematical working to justify your answer. So here you can't just go, oh, Ben's the winner or Anna's the winner and get a mark. You need to be able to prove it in order for your statement to be counted. So what we want to do here is to show both the comparison between their totals and then the winning score, which is the one that's closest to 1.1. So in order to do that, it'll be a case of doing their score. So for Anna, it'll be -1.6. Okay, and we want to take away -1. And for Ben, we want to take away -1. So take -1.6, take away 1, which is effectively +1, is going to give them a score of -0.6. And here, -0.7 plus 1 is going to give them a score of 0.3. And so we can see here that Ben is 0.3 away from -1, and Anna is 0.6 away from -1. So Ben is closer, so therefore Ben is the winner. Okay, next question looks at the idea of making a hat and tells us the materials that are required. It tells us we need 0.25 amount of silk, and it's $50 for that per metre, and 0.8 of a metre of wool, and it's $35 per metre. So this gives us this equation here. So we want 0.25 of silk, and we want to add onto that 0.8 of the wool. So then we can turn that into an equation. 0.25 of becomes times, and the silk is worth $50. And then we want to add onto that 0.8 of wool, which is $35. 0.25 of 50 gives us 12.5, and 0.8 of 35 gives us 28. And then if we add those together, that will give us a total of $40.50. Just note here that you can't write 40.5. You can't write it like that. It's got to be 50 cents because it's a dollar amount. You've got to have both two decimal places in order for that to be a correct answer. Okay, here we look at the idea of taking a cost price and we're going to turn it into a selling price. And that selling price has to include two additional amounts, and that is the markup, which is how much profit the seller will make, including the government GST on top of that as well. So the markup will be of this cost price. So it's 100% is the cost price, and we're going to add on the 72%, which is the markup. So that equals the selling price less the GST at that point. So that equals 172%. So we want 172% of this original cost price. So 172 over 100 of becomes times cost price is $40.50. Obviously don't forget that this is a calc active task, so you can then, if you wanted to, you could do that as 1.72 multiplied by $40.50, and that will give you a value of 69.66 cents. We then want to add on to that 10%, okay? So we can then go, well, it's going to be the same process as here, where it was the cost price plus the markup. This becomes this value plus 10%. So we need to add 10%. So we can multiply that by 110%, which is obviously 100% is this amount, and plus the 10%, which is GST. Now that obviously can become 110 over 100, and that can become 1.1. So we can take that 1.1 and we can multiply that by this amount from the previous part of the question, $69.66 multiplied by 1.1, and that will end up giving us a value of 76.626. And then the question says to round it off to the nearest whole number. You've got to remember this is a selling price, so they're going to go for the price that they want from marketing point of view. So that would become then $77 as the nearest whole number. Okay. Some parallel lines here. So we've got to find some angles here, and we can see here we've got these two parallel lines, and we've got a line cutting through here. And we can see here that we have A and 40, and so these are alternating angles. So A is going to equal 40, and the reason is going to be alternating. So it's an alternating angle. A alternates with 40 there. Now you could do this, then the next one here is we have this B and we have this co-interior. So the co-interior would be in here. So we're looking at that parallel line there, all the way down there and across here, creates this co-interior angle, and that co-interior angle has to add up to 180. So B is going to be equal to 180 take away 50. So that's going to be 130. Okay, put a degrees on here. And that's going to be co-interior. And here you could put an added 180 take away 50 equals 130 degrees. Okay, as you answer there. And that means that now on our diagram, we can fill in some of those missing elements. So we have 40 here, and we have 130 here, like this. Now, what this tells us then is that we've got this triangle here where we have 2 degrees here and we've got one that's missing. So 50 and 40 equals 90, and a triangle has to equal 180. So that means the missing angle here is 90, and C is vertically opposite. So C is going to equal 90 degrees here, and the reason is going to be vertically opposite. Finally, the geometry question at the end. So Cartesian plane, and we're going to do a rotation, and then we're going to do a reflection. Now, it asks us to rotate clockwise. So clockwise is going to be in this direction, okay, so around clockwise, and it asks us to do it around the point here, 1, 1, okay. So we mark that here. So now what we need to do is to consider, we're moving this clockwise. So the way I would describe the best way to look at that is to imagine this here like this, and then if you are moving it clockwise 90 degrees, you can see how that swings around. So I'll do that for you again here like this. So that's there, and then as it moves around like a clock face, it moves around in that direction. So what's going to happen is our drawing on this side is going to end up looking like this. It's going to have that rotation to it. So have that firstly as your visual as to how this is going to work, and now we just need to place it in the right spot. So what we do is I take the place that's the point here X, which is closest to our rotation point, and I need to go across 2 and down 1, okay? So here from here I can go across 2 and down 1, and then that becomes my new X value point. So that becomes X1. And remember, I'm rotating it that way. So that means that my Z is two across, so it's going to go 2 across, and that's going to become my new Z. And that's going to be my X, that's Z1 there, and that's going to be X1 there. And then, as we described before, we've got that rotation happening. So we can see here that that's 1, 2, 3 across. So we need to go down 1, 2, 3, and this one here. And so that becomes our new diagram, like that. Okay, new one like that. All right, now, obviously, on a proper Cartesian plane, that'll look a little bit neater, but you can excuse me in that regard. So now we can just label that. So we've got our X to the 1, Z to the 1, Y to the 1, and now that becomes A to the 1. Now that's important because the next part of the question references that. Sometimes the confusion with these questions is, oh, which one do I have to reflect? Is it the original diagram or shape that I'm given, or is it the one that I've moved? And in the question it references the A to the 1. So now that we've actually labelled it, we can make it really clear which one we're moving. Okay, it then says that we want to reflect it about the x-axis. Okay, so the x-axis is this one through here. Okay, so that axis there is x. Okay, and because this one here is y, of course. And we want to reflect it across that. So it's going to be reflected to the other side. So it's down 1 here, so it goes up 1 to there. And the same as here. So this gets reflected that way. So it turns, you can see how it turns upside down. So it's going to have that shape. And then that goes across 2 and then up 3. 1, 2, 3, like that. And then that becomes our final image here. And so there's our rotation and here's our reflection